everybody who is watching this video. My name is Olenjolai Single from Tanzania, and this is our national flag. I'm very happy to have you today. I would like to take this opportunity to welcome you, and I have a good news for every national and international viewer, because we are going to discuss about the beauty of higher engineering and scientific mathematics, and especially the subject that called the linear algebra, which is fundamental subject for undergraduate level. So I'm overwhelmed with very important informations and the details of the titles and subtitles that I've written on the blackboard, which I want to pour out to you. So let's take this opportunity to welcome you again once again now is online institution that called Online Undergraduate Polytechnic Institute of Tanzania in square bracket OLENJOLAIM. Again, I would like to take this opportunity to welcome you into our YouTube channels that called Online Undergraduate Polytechnic of Tanzania in square bracket OLENJOLAIM. So we are very happy in these online institutions. First of all, it's we are dedicating, or we are posting, or we are uploading, or we are adding the contents which are specifically for undergraduate students. Well, so what the vision that we have in Tanzania online undergraduate online and what the vision that we have in Online Undergraduate Polytechnic Institute of Tanzania in square bracket OLENJOLAIM. Well, so as I said, that my name is Olenjolai. I will be teaching you higher engineering and scientific mathematics for undergraduate students. And this is an assignment that we have from God, that we have an assignment to teach, to incubate, to train, to mentor, to lead, and even to encourage some group of students who would like to extract knowledge from the formal or informal educations of the classroom instructions, and combining the knowledge that we extract in the class, whether formally or informally, and with the knowledge of the Word of God that we extract also from the Holy Bible, in order to combine these two knowledge to solve real life problems. So our visions are 4 parts: understand the knowledge of the classroom instructions of the formal and informal education, or also to understand and extract the knowledge from the Holy Bible. And the third part is combining these two knowledge, and the fourth part to solve real life problems. So you are the students right now. We like to challenge you from the beginnings when we are going to deliver these contents to you, and we are going to teach you step to step by using different teaching aids, by using different teaching techniques. Then we ask you that to think and even to challenge yourself. How can you take these informations and convey it into the convey to become a solution of the particular problem from your family, from your community, or from your village, or from your district, from your city, from your country, and even from your continent. So it means that we have been surrounded with so many problems, real life problems that I call them, of the small scales, medium scale real life problems, large scale real life problems, and even extraordinary large scale real life problems. So myself, I'm a product of the assignment that I'm telling you right now, and also I'm a product of the knowledge I've been extracting formally and informally. I'm also a product of the knowledge of the Word of God, and right now I'm solving a real life problems which seems like complex, because many teachers didn't bother themselves on how they can have a unique way of teaching, and the advanced way of teaching, and using the digital technology on teaching different students. But that's not the issue. The issue is the different techniques and the way that I'm going to simplify the contents for every student to understand and even love the subjects that I'm going to teach you. So, well, we have so many things to do in our Online Undergraduate Polytechnic Institute of Tanzania. And again, I want just to tell you that we have so many departments. We have more than 2 departments in this online institution. But again, that in all of those departments that will be trying our level best to pour out and trying to use different techniques to make sure that we help everybody who wants to get help from us. Again, this is the national programs, and also it's the international programs, because mathematics is international subject, it's a universal subject that I used to call it. It's not, even in Tanzania, we have never discovered any piece of mathematics that we are studying in undergraduate level. We have been adapted from the European countries, from the Asians, and from the Americans. But I believe that there is a time for us also to just to contribute something in mathematics for the rest of our lives. So we believe there's a lot of things that can be done, and that's why that we are doing, and we're trying our level best to make sure that our students, they get good education, and they got actual high qualified educations, and they think differently so that they can do great things more than what has been done in the previous generation. Again, we have in departments of high engineering and scientific mathematics. Today, the course of the modules is linear algebra. We are using the curriculums of University of Dodoma that's called Udom. However, that these contents will be universal, may be used in any continents, in any country, in the African continents. So we are in chapter 1 that's called Matrices, at one of the chapter that we have to cover in linear algebra, but in different ways, because we begin from the fundamental matrices, and then we take you into special types of or special matrices that we have to understand them, or we have to learn and understand it for the first time in undergraduate level. Again, we are in lecture 2, we are done with lecture 1, so when we have introduced the what the means of matrices, the size of the matrices. So today we are teaching about special types of the matrices, and in many institutions or college or university, this module or this course is being taught into the first semester in the first year of undergraduate studies. Okay, so now I don't want to waste much of your time, so it's a moment right now. I ask a serious students to take his pen and take his calculator, scientific calculator, to take your own exercise book, and let us go to the business right now. Let us begin with the quick review. The quick review of what? Of lecture 1. So in lecture 1 of linear algebra, here we have discussed so many things. First of all, we discussed definition of what of a matrix. So what is a matrix? So we define it. And then simply we say that a matrix, it can comprise either a row, or it can comprise column, or it can comprise both rows and column. Okay? So that's the matrix. But again, we discussed or we presented to you the meanings of size of the matrix. Size of the matrix, this is defined by the number of elements or number of rows and number of columns. So you say, for example, the size of the matrix is expressed as M times what, or M cross N. So M representing row, and N always representing column. Okay, so we say that for instance, if you have a matrix A, and this is 2, 4, 5, 6. So here we have how many rows? 1, 2. So you have 2, and then this we call it 2 by. So how many columns? 1, 2, 2 by 2 matrix. So 2 by 2 matrix. So we have done a lot of things. The lecture 1, which is titled as general introduction of the matrices in advanced in square bracket in Udom, is still in our YouTube channel, so you can access. So let us go to the special types of the matrices. So special types of the matrices. So I don't know about, I think I've tried my level best to universe just to put in a big picture every concept that we are going to learn, so that to cover the contents for other students who are studying in other institutions or colleges or university. However, that our syllabus will be using Udom. So, but in many aspects that we can take you beyond what Udoms they have to cover. Okay, because we'll be focusing what undergraduate students has to cover. So let us start our interesting subject of the day, that we say that in engineering, because we are engineers and we are also scientists, we are engineers and scientists. In the engineering, and scientific mathematics, we say that there are different types. There are different types of matrices. Which are basically categorized. These types are basically categorized due to on the basis of these factors, The first factor that you have to check when we are categorizing the matrices, the value of the elements. The values of the elements of a matrix. These values can categorize them. For example, if the values of the principal diagonal is equal to 1, while other values are 0, while other values of the elements are 0, that's what we call identity matrix. Again, if all the values in the principal main diagonal of the matrix are equal, but can be any number, maybe 7. So that's another type of the matrix that I'll be teaching you. So that's why that we call them. For example, if the values of all the elements found in a matrix is 0, then that is another type of the matrix we call null or zero matrix. So this is the first factor. The second factor that we can check or we can use, order of the element. How the elements are ordered. Order of the elements. For example, you can find that elements below the main diagonal. I will be talking about main diagonal and leading diagonal because we have introduced to you that concept during your ordinary level and even during your advanced educations or ordinary diploma. So for example, if the elements are below the principal or the main diagonal is equal to 0, then that's what we call the upper triangular matrix. And if the values below the principal or main diagonal are equal to 0, are not equal to 0, means that they are not equal to 0, while the elements above the main diagonal are equal to 0, then that's what we call the lower triangular matrix. You see? So that's what we say, that order of the elements. So you can have the same matrix, but if you change the order, then we are going to have a new type for the matrix. Then again, this depends on the number of columns. For example, we have horizontal matrix and the vertical matrix. Horizontal matrix is the matrix which have more number of rows, or which have more rows compared to the columns. And vertical matrix is a matrix which have greater, or which have more number of columns compared to the number of rows. So you see that the means of number of columns. So number of columns can decide also the type of the matrix. And the last factor is number of rows. So number of rows also can decide the type of the matrix. Okay, so let me teach you some types. I've prepared the 10 types of 10 special types of matrices, some special types of matrices. Okay, of matrices. So let us begin. So I will be teaching you quickly. You can pause the video and review this video several times as well as you can, because this is just a review of what you've learned. The first special types is called raw matrix. Raw matrix. Say raw matrix. So what is raw matrix? I'll be defining, give it a general formula, then give you an example, then we ask, okay, we believe that we have already understood. So what is raw matrix? So simply say that the raw matrix, so my question today, I don't write it, I'm asking the oral, right? Raw matrix, you say that is a matrix, which comprises the row only. Don't have a column. Okay? The row only. That's why I call it a raw matrix. So there is one column, which is general for all. So for instance, that we used to say that if you have matrix A, then you can have A, I, J, and then here we have M times N. This is representing size of the matrix. M representing number of rows, N representing number of columns. So because the row here, the column is the same, have the same number, there's the same column, so you say that the row, because this is the raw matrix, so we have so many columns, and we have only one row, which is the first row, so it will be A1J, and hence we have only one row times by what? By N. So what example? Also with that I've been speaking difficult language to you. B, this is equal to what? Is equal to 21, 7, and then 14. This is the raw matrix. Why? Because we have only one row, but we have more than one column. So that's what we call the raw matrix. If you have any question, don't hesitate to ask in the comment section of this video. I like questions, and I like questions, so I'm waiting your question in the comment section. And you know, many of my students, when I was teaching them physical, they used to say that we have understood everything, we have no any point to ask a question. That's the first special type. The second special type we call the column matrix. Say column matrix. Column matrix. Again, say column matrix. What is column matrix? It's just like a raw matrix, but it's a little bit different. It is opposite of raw matrix. This is the matrix which comprises only what? Column. Just it comprises only columns. There's no only column. Only column. So there it comprises row. So here only column. So simply we say that column matrix is a matrix comprises or consisting comprises only column, only column matrix or column vector order. So this the general formula of it. It will be let's say Bij, so we have M cross M. So what is common here? So the column is going to be the same, but the row is going to be different. Going to have more than one row. So this will be B, I is unknown, 1. And then we say that this is M by 1. It's just like there, we say that is 1 by M. This is N M by 1. So then, if that's the case, we say that resistance, we have a row matrix, a column matrix. In example, we have B. This is equal to 3, 6, 9. So this is the column matrix. So we have one column, we have how many rows? 1, 2, 3. So simply, this one in terms of size, we define as 3 by 1. 3 represents number of rows and 1 represents the number of columns. So that is all about what column matrix. Ken, if you have any question, don't hesitate to ask in the comment section. So, what do you think? What could you have as mathematicians if you find that a matrix comprises both rows and columns? And then we find a special condition that the number of rows equal the number of columns. But before that, let me teach you about the said special types of matrix we call the zero or null matrix. Zero or null matrix. Zero or null matrix. So zero or null matrix. Zero or null matrix. What does it mean? So zero matrix simply say that this is the matrix holds all elements. The zero matrix is a matrix whose all elements are zero. All elements of that matrix are zero. And we can have a simple so you can have a matrix C, and this matrix C is 0, 0, 0. Then we have matrix D. Then we have 0, 0, 0, 0, 0, 0, 0, 0, 0. So this is the zero matrix or null matrix. So all of its elements are equal to 0. So this is it's a matrix which does not need computation. It just makes all of its elements equal to 0, so it does not need confusion. Then afterwards, we say, what if we have a matrix which comprises row matrix and the column matrix in such a way that the number of rows equal the number of columns? That's a very important matrix that we'll be learning in all level or in ordinary education, secondary educations, and even in advanced secondary education. That's called TOT square matrix. So if you want to write the size for this matrix, then we say this is 2 by 2. Also, if you want to write size for this matrix, this is 3 by 3. 3 number or 3 column, 3 rows and 3 columns. Then we go for the first type. Okay, first type. So the first type we call it square matrix. Square matrix. Square matrix. Say square matrix. Again, say square matrix. Simply, this is what is square matrix? That's the question that you have to pose yourself. So you say that square matrix you say that is a matrix whose number of rows is equal to the number of rows is equal to the number of columns. Number of columns. So square matrix. So square matrix is the matrix whose number of rows is equal to the number of columns. That's all. So in square matrix, the number of rows is equal to the number of columns. So in this case, we say that generally, we say that for instance, you have matrix A, then here we have A, I, J, M by N. But for square matrix, and this is the common type, we say that M is equal to N. Number of rows is equal to the number of columns. So it means that we can say that this generally will be matrix A, then A, I, J, then N by N. This also is equal to, if you say A, I, J, then we find is M by M. The signs will be the same. I may give you an example of the square matrix. Afterward, I will take you into the fifth type of the special matrix. If you know these types of matrices, you have learned them somewhere, you can pause the video and then try to ask yourself the meanings of the matrix, why we have matrix in mathematics. So example, I have two examples to explain that concept. So we have a matrix A, 2A, M6. So these are how many rows? So here we have 2 by 2. Then you have B. Okay, B. So we have 100, 55, 15. Then we say that this is 25, this is 41, and this is 0. The number of columns is greater than the number of rows, so it's not a square matrix. So it means we still need some other 30 values. So here we have 56, and then there we have 17, and here we have 16. So that's the square matrix because it is 3 by 3 matrix. Interesting. You see how higher engineering and university and scientific mathematics is beautiful? I see that now you are laughing that, wow, I understand this concept right now. Okay, so that is the first types of the matrix. Ladies and gentlemen, allow me to take you into the fifth type of the matrix, which we call it identity. No, we call it diagonal matrix. Say diagonal matrix. Say diagonal matrix. Diagonal matrix. Diagonal matrix. Diagonal matrix. What is diagonal matrix? Have you ever heard anything else about diagonal? Yeah. You heard it where? You heard it for the first time during your ordinary educations, during your form 4. Right? Diagonal matrix. So what's diagonal matrix? When we say diagonal matrix is a matrix whose all of its elements So diagonal matrix is a matrix whose all of its elements are 0, except elements of principal or main diagonal of the matrix. Its elements are 0, except the elements of what? Elements of principal or main diagonal. Diagonal matrix, we say diagonal matrix. Diagonal matrix said that the matrix whose all of its elements are 0, except the elements of principal or main diagonal. Principal or main diagonal. Is a matrix whose all of its elements are 0, except the elements of the principal or main diagonal of the matrix. Just to remind you, for instance, that I have a matrix which is A, B, C, D. Main or principal diagonal. And then this one, this is minor diagonal. And this is main or principal diagonal. So this is principal diagonal, this is main diagonal. Zero. Then here we have 0, 5. So this is diagonal matrix. Why? This is the main diagonal or principal diagonal. It's none of these elements which is equal to 0. But the main elements are 0. So I still have 3 types of matrices, then I'll leave the homework for you. So get prepared. Then this now, ladies and gentlemen, is called the identity matrix. Identity matrix. Say identity matrix. Identity matrix. We are learning diagonal matrix. Now it's identity matrix. What's identity matrix? Or in other words, we call it unity matrix. Because in word problems, you can the author of the book might mention identity matrix or unit matrix while he is thinking that in his mind. The matrix equals all elements whose all elements we say that all elements of principal or main diagonal, all the elements of principal main diagonal are equal to 1. Main diagonal of the matrix is 1. We say that identity matrix is the matrix whose all elements of principal main diagonal of a matrix is what is 1. So this is identity matrix is notated as I. Second half identity matrix of 2 by 2. So 1, 0, 0, 1. So this is 2 by 2. So our identity matrix for this case here we have 0. We usually end with this when we are playing a draft. So then we have 0, 1, 0. Then have 0, 0, 1. That's is another example of identity matrix. And about it, we have horizontal matrix. Say horizontal matrix. So if you have horizontal matrix, you have to expect that we are going to have so we say that horizontal matrix. What is horizontal matrix? Horizontal matrix, we say that horizontal matrix is simply say that is a matrix horizontal matrix is the matrix whose number of columns of a matrix takes whose number of column of the column. So it's a matrix whose the number of columns of the matrix is greater than the number of rows. So whose number of column in a matrix is greater than so that where the number of columns in a matrix is greater than the number of rows. Is it? Whose number of columns in a matrix is greater than the number of rows. So this is the example of a matrix horizontal. So here you see that the number of rows is greater than, number of columns is greater than number of rows, and vice versa is true. So that's your horizontal matrix. So example that you find the number of columns here. We have 1, 2, 3. We have 3 columns. We have 2 rows. So this we call the horizontal matrix because it is being arranged in a horizontal plane or axis. The 8th example is called the vertical matrix. Ladies and gentlemen, I'm about to finish this lecture, which is lecture 3 of linear algebra. So I'll say vertical matrix. What is it? So vertical matrix say that vertical matrix, we say that is a matrix vertical matrix is the matrix in whose the number of rows is greater than the number of columns. So it's a vertical matrix. Vertical matrix, the matrix in which the number of rows is greater than the number of columns. Greater than the number of columns. So it says simply, give the example of this type. You have matrix P or matrix Q. So -1. How many rows do we have? 3 rows. 1, 2, 3. We have 2 columns. So this is our example for vertical matrix. Okay? Ladies and gentlemen, let me upper and lower triangular matrix. Say upper and lower triangular matrix. Upper triangular matrix and lower triangular matrix. What are they and how do we form them? That's a very important point. What is upper triangular matrix? Upper triangular matrix. So upper triangular matrix, you say that upper triangular matrix, you say that is n square matrix whose elements below the diagonal are all 0. Is n square matrix. Upper triangular matrix, the n square matrix. Whose elements below the diagonal are all 0. Is n square matrix whose the elements below the diagonal the main diagonal are all 0. So upper triangular matrix, you say the n square matrix whose the elements below the diagonal are all 0. Let me give you an example. 1, 0, 0, 2. So you see from this matrix, what the definition say that upper triangular matrix is the n matrix in whose the elements below the diagonal, where the diagonal is the below the is the diagonal first of all. below the diagonal, above the diagonal. Okay, below the diagonal, above the diagonal. So that's the linear diagonal. Matrix. Lower triangular matrix, say N is N square matrix. So lower triangular matrix, you say that the N square matrix, who's the element whose elements above the diagonal, above the diagonal, above the diagonal, is the N square matrix whose elements above the diagonal, above the principal diagonal, are all 0. Example. So then we come diagonal are all 0. So above the diagonal, okay, so we say that we have matrix P of what? First of all, it is what? It's a square matrix. Okay, so then we have that example. You find that all the numbers below this main diagonal, which is actually that in this case it's a little bit challenge. So these are the zeros above what the diagonal, and here the zeros are below the diagonal line. So we have the diagonal for this case. It's a little bit challenging because of it's not a square matrix. So it's a little bit challenging to show the middle value. So then that's the nines, this the tens, which is called the scalar matrix. So this is scalar matrix. It will be your homework. Briefly explain the meaning of X. Briefly explain the meaning of 0 times a certain number. So briefly explain the meaning of 0. The meaning of what? The meaning, explain to me, briefly explain the meaning of scalar matrix. Then that is briefly explain the meaning of the scalar matrix. Please reveal the examples. Please reveal the example. Let's reveal the examples. Okay. So I'm very happy that this is the end of lecture 3, lecture 2 of special case of the matrices. I thank God who have created me in His own image. I thank God who have been faithful in preparation. I'm sorry also because it was I was having a lot of stops, especially at the end of the session. But don't worry, everything's gonna be settled. And I thank God for you who have got this chance to be with me and to join me. I really remind you how you can do the registrations into online undergraduate Polytechnic Institute of Tanzania, square bracket OLENJOLAIM. First of all, just sign in the YouTube. And then another thing that I would like just to insist you, make sure that you click the buttons of subscribe because we are going to upload more than 500 videos in our online undergraduate Polytechnic Institute of Tanzania square bracket. It is OLENJOLAIM. So may God bless you abundantly, and actually we thank God and we ask you to share these contents with your colleagues at University of Dodoma or any institutions around our nation, and then make sure that you read the descriptions in order to get so many information. Again, is that in case you want to offer your free willing Thanksgiving or your free willing seed or any kinds of the seed, and hence we ask you that please you can send your gift or your offering through this telephone number 0759 74 53 10 31. So I really thank God who have given you this chance. I invite you in the next session, which will be session 3, when I will be taking you from the point where we ended. Make sure that you do this homework, and you make sure that you ask many questions in the comment section, and make sure also that you ask the questions to other colleagues that they can go through it. So now it's a time for you, and it's a time for you to become victorious, especially that in these scenarios, so in these models of these courses. So may God bless you. I'm praying for you. I ask you to pray for me. May God bless you until we meet. Amen.